All right, so section 3.1 is on the rectangular coordinate system, and the first thing in our notes, it's asking us to construct a table of values for the equation y equals 3x plus 2, and it gives you the x values it wants you to use. So we have -3, -2, -1, 0, 1, 2, and 3. If you do have a graphing calculator, it makes this question so easy. You will never get it wrong. You just have to know what buttons to push. If you don't have a graphing calculator, you will have to do math to get your answers, and then it's more difficult because you can make mistakes. I'm going to show you both ways. Here's what the calculator does, which is what you will be doing by hand if you don't have a graphing calculator. You take the value of x that it wants you to use, and you replace it in for this equation here. The equation says take 3 multiplied by what x is. In this case, they want you to replace -3, and then add 2 to it and get that answer. Not that bad. I mean, it's just 3 times -3, which is -9. -9 plus 2 is -7. But you'll have to do that this many times instead of just getting the answer automatically with your graphing calculator. The solution point is the x value, which is -3, comma, the y value, which is -7 in this case. If you have a graphing calculator, then what you can do is use that graphing calculator and use the y equals screen. So for those of you who don't have a calculator, you can ignore me at this point and keep going through getting these values by hand. If you have a graphing calculator, I'm going to show you what that would look like on there. So you would go to your y equals screen, top left-hand corner. In the y equals screen, you're going to insert the equation that they want you to use, which is 3x plus 2. To get to the table, you hit second graph, and it brings you to a table. Your table right now might be going by ones. It might be going by something different, depending on whatever you did last with your graphing calculator. If it's not right, hit second window and change the table. Start wherever you want. In this case, it wants you to start at -3, so mine's set up starting at -3. And this right here tells you what to go by. Right now, mine's going by ones, which is what this one wants you to do. If it wanted you to go by 0.5s or 10s, then you could change this. But I have mine starting at -3, going by ones. Then when you hit second graph again, you should be able to see the table of values that they would want you to insert here for your solution points. So instead of having to do all of the work by hand, if you have a graphing calculator, all you need to do is copy the numbers here and then write in the ordered pairs here. So I'm going to give everyone a minute to do that. Well, not a minute, a couple minutes to do that, and then we'll go over the answers together.
I'm going to trick Steve into frying it and then tipping it over. The porta potty, I'm going to tip it over while he's in it. I'll be like that, okay. I think something else.
Oh, plus like, oh, it's plus 2 equals -7. I know the calculator, but it doesn't have very value. I'll step up.
Someone gave me this for Christmas, like, yeah, and they were like, we're going to need this in the future. Like, okay.
We'll make it like most of it can go on.
Cool.
All right. Are we good here? We still need another minute. Yeah.
Are we gonna need these every single class, or should I keep them like that?
Yeah.
I just didn't know we would need.
Oh, it's okay. All right, so we're going to be just basically, if you have a graphing calculator, you're just copying all these solutions, -4, -1, 2, 5, 8, and 11. And then the solution points are basically every x value with its y values. This is -2, -4, -1, -1. Remember, it's x comma y, 0, 2, 1, 5, 2, 8, and 3, 11. Then, I'm not sure if I told you to do this or not, then over here to the right, it wants us to graph these solution points. So now we're going to take some time to graph. I'm going to do it as well, but my board is a little bit off. It's not perfectly calibrated, so mine might not be perfect. But the first point I'm going to plot is -3, -7. -3 on the x means start at 0 and go 3 to the left, and then down 7. So right around here. -2, -4 would be 2 to the left, 4 down. -1, -1 would be -1 to the left, and then down 1. 0, 2 would be right on the y-axis, just up 2. 1, 5 is to the right 1, up 5. 2, 8, over 2, up to 8. And then the last one doesn't quite fit, over 3, up 11 would be a little bit above 10 there. Once you plot all those points, you can see that this creates a linear line. I could tell that from the equation because the equation's in slope-intercept form. So if you remember from Algebra 1, learning all about linear equations, y equals 3x plus 2 would be creating a straight line. We don't have rulers. You don't have to connect them or anything like that. We can just get some practice plotting points again. So the next part of section 3.1 is going over different formulas. I have to talk to Mr. Harmon to see if we are going to be requiring you to memorize these formulas, which would be rough, or if we're going to be giving you the formulas on the quizzes and tests, which would be better because then you don't have to remember all of this craziness. Basically, all you have to do is follow the formula. So it's just essentially putting numbers into formulas and then putting those numbers into your calculators and hitting enter if you have a graphing calculator, or if not, you will have to use the order of operations to solve, which is a little bit more difficult. Let me show you what I mean. The first formula that we're going to be going over is the distance formula. The distance formula finds the distance between 2 points. If these 2 points are on the same vertical or horizontal line, you could just count and see how far apart they are. But as soon as they become slanted and 1 point's here, 1 point's here, you can't count anymore because the boxes are not equal 1 unit away. So if we wanted to find the distance between these 2 points, first let me just sketch a graph so I can get an idea of what they look like. And if I ever ask you to sketch a graph, here's what I want you to do. Draw an x and y axis and then just like put some dash marks here for as many as you would need. I'm going to start with 3 above and below. So right now I have everything from -3 to 3 for the x and y. But I might need to make this a little bit bigger to fit everything in. Then I'm going to plot my points. -1, 2 would be over 1, up 2. Now obviously this is not going to be accurate. This is not like an accurate graph because not everything is equal. This is a sketch, so I can get an idea of what this looks like. And then when I try and plot 2, 4, I realize I didn't make it big enough, so I need one more line here. So 2, 4 would be about here. Now I can see the 2 points I'm trying to find the distance of. These points are not straight across from each other horizontally or vertically, so they're on a slant. I have to use the distance formula. The distance formula is right here, and it looks like it's a bunch of craziness, but if you remember back to Algebra 1, in Algebra 1 you use the slope formula, and it looks very similar in that you have x2, x1, y2, and y1. So you should be kind of familiar with the formula and using those types of things. So the 2 points that they give us, I know it's kind of silly, I'm basically going to be doing this again to the right, but if I just gave you these notes and said, here you go, I'm sure you wouldn't know what to do. But by the way, if you plan on going to college, this is how they will do it. They'll say, oh, here's section 3.1, and then it'll tell you, like, all right, chapter 3's test is next week. You have to learn on your own, FYI. But here's what you would do. The 2 and 2, 4. When I'm given 2 points, the first point that I see to the left, I consider the first ordered pair. The second one is the second ordered pair. So if each ordered pair has an x first and a y second, this would be an x, this would be a y, this is an x, this is a y. But because this is the first ordered pair that I wrote down, I'm going to say this is the first x and the second y. That's what the little 1 and 2 represent. X1 means the first x. Oh, why did I put y2? That should say y1. Excuse me. Erase that. I'm sure you just copied what I did. That should say y1. So this is the first x and the first y. This is the second ordered pair. So this is the second x and the second y. So that's what the x2, y2 represents. So now all we're doing is taking these things and replacing them into this crazy formula. The formula says the distance between 2 points is the square root of all this stuff. Basically, you subtract the x values. You take x2 and subtract x1 and then square it so it's not a negative number. And you add that to the y's, doing the same thing. You subtract the y's and square it so it's not a negative number. So this is the formula. Now I'm just taking the numbers in for x1, y1, x2, y2, and replacing them in where they go. So for x2, the x2 number, I look over here, it's 2. So in the formula, it's going to be in parentheses 2 minus. x1 is negative 1, so just be careful, it's going to be minus a negative 1 squared, plus y2 is 4, y1 is 2 squared. So all I'm doing right now is just replacing numbers in for variables. Sorry, this is not looking pretty, but that square root line should be across the whole thing. If you have a graphing calculator, you could use your graphing calculator and put it all in right now, and I'll show you how to do that in a second. But let me show you how the graphing calculator gets your answer. It simplifies it as much as possible, and then takes the square root of it last. 2 minus negative 1. Double negatives really mean plus. So this is really 2 plus 1, which is 3. This is 3 squared, which is 9, plus. 4 minus 2 is 2. 2 squared is 4. So this all simplifies to be 9. This simplifies to be 4. 9 plus 4 is 13. So the answer is that these 2 points are square root of 13 away from each other, which makes no sense because what is the square root of 13? Then you would put that in your calculator and put the square root of 13 in by hitting second x squared. And it's about, let's just say, they did 3.61. I'm just going to say 3.6. Depending on what I tell you to round to, the nearest 10th, 100th, you'll get a different answer, but it's about 3.6 units away from each other. That's how you would do it by hand if you didn't have a graphing calculator that can do it all in one step. Here's how you can do it with the graphing calculator all in one step. So you quit out of the y equals thing because you don't need that. And then we're starting here at this page, and we can do it all the way from the very beginning. You would go to second x squared, and it brings up the square root symbol. You have to use the parentheses just like the formula says. So you have to use the left-hand parenthesis, 2 minus negative 1, close the parenthesis, and square that. Plus, you have to open up another parenthesis, 4 minus 2, close the parenthesis, square. Look at your work on the page, and then look at your calculator work to make sure everything matches. Make sure the squares are in the right spot. Make sure the parentheses are in the right spot. If something's in the wrong spot, you're going to get the wrong answer. But as long as you are very particular in typing these numbers in correctly and everything the way it looks, you hit enter, and no math is required from you. Your calculator will do it all for you, which is nice. That's why the graphing calculator is amazing, as long as you know how to use it. So you get the answer automatically. It's 3.6. You basically didn't have to show any work. You just had to show how to put the numbers in correctly, and that means you know how to follow a formula. So that's the distance formula. We use the distance formula to find the distance between points. I mean, simple enough. But we can also use it to tell if 3 points on a coordinate plane create right triangles, let's say. So I'm not really sure because obviously I'm new to the school. I'm not exactly sure what's in the curriculum for geometry, but I'm assuming since you guys took geometry before Algebra 2, dreaded geometry, right? That you probably went over the Pythagorean theorem. The Pythagorean theorem says that if you have a right triangle, every right triangle has 90 degrees, and the right triangle, what happens here is the side across from the right angle is the hypotenuse. It's the longest side. These sides are considered legs. Doesn't matter the order. The two legs, you can call them A and B. The hypotenuse is always C. The Pythagorean theorem says that if you take the legs, let's say A first, and square it and add it to B squared, it's equal to the hypotenuse squared. So the reason why we're talking about this again is if we have these 3 points, and I'm going to just sketch them, 1, 2, 3, 1, and 4, 3. If I sketch these 3 points, I'll start with 1, 2, 3, 1, and 4, 3. I know mine's not very accurate, but if I was to connect these points, and if it was on actual graph paper, it would look better. They're saying that this is a right triangle. And what we're going to use is the distance formula to determine if that is true or not. So what happens here with the distance formula is it says if you find the distance of these 2 points, and these 2 points, and these 2 points, and use the Pythagorean theorem, it will work out. That means that these 2 legs squared and added together will be equal to C squared. So I'm not going to do the whole thing. I'm just going to show you what this is saying. Basically, what this distance formula is showing us that the distance between this point and this point is equal to the square root of 5. So this distance right here is the square root of 5. Which, like, I'm not sure what that even equals, so let's see. It's about 2.2, let's say, units. And then they found the distance of these 2 points. And the distance of these 2 points is also the square root of 5. So this is also about 2.2 units away from each other. Then they found the distance between the hypotenuse points, the longest side. And when they did that, they got that this is the square root of 10. So when they found the distance of these 3 points here, they realized that this is a right triangle because when you take the square root of 5, square it, add it to the square root of 5 squared, it equals the square root of 10 squared. And this is the Pythagorean theorem, which says take the 2 legs, square them and add them, it'll be equal to the hypotenuse squared. Well, the square root of 5 squared really equals 5. When you square a square root, they cancel each other out. And you can double check that by taking your calculator and doing like the square root of 5 squared. You're going to get 5. And this equals 5 as well. And then the square root of 10 squared equals 10. And this is true. 5 plus 5 does equal 10. Because of that, this is a right triangle. So what this problem is like an application of geometry with Algebra 2. And I'm sure you guys are so passionate about that. Just as passionate as I am. Okay, but moving on to the next page. The next thing we have here, and I know it's a lot of notes. We're almost done with notes and almost getting to practice. So stay with me, bear with me. The next thing we have here to look at is using the distance formula to tell if points are collinear. This is a vocabulary word that you're going to need to know. Collinear means that points lie on the same line. Points don't have to lie on the same line. Points could be all over the place, but they're trying to prove that point A, B, and C are on the same line. Looking at them, they look like they do, right? If I took a ruler and drew a line, I could probably hit all 3 of those points. They look like they lie on the same line, but what we're going to do is use the distance formula to prove that that is true. So to figure out if points are collinear, what you do is you find the distance between the first point and the second point first. And they did that. Here, in this example, they found that the distance between A and B is 5 units. In the second example, they then found the distance between B and C. So they used the distance formula to find the distance between B and C, and they found that's also 5. So they found that this is 5 units away, and then the first one's 5 units away. So if we look at this line, I can see that from A to B it's 5 units, and from B to C it's 5 units. And then to determine that it's definitely collinear, you then need to find the distance between A and C. You then need to find the distance between A and C, and that should equal 10. Because if from here to here it's 5 and here to here it's 5, then altogether that should be 10. And you can see in this last example, when they found the distance between A and C, it equals 10. So to find out if numbers are collinear, you have to find the distance between the first two, the last two, and the first and last to make sure that the first two and the last two added together equals the whole entire line. If so, they're considered collinear. One last thing before we're going to practice some of these, which is just using formulas. The last formula is the midpoint formula. The midpoint formula finds the middle point between 2 points. So instead of finding the distance between 2 points, this is an actual ordered pair. Notice the formula is in ordered pair form. Your final answer will be something x comma something y. That's what your answer would be. If I said find the midpoint, your answer will be something in ordered pair. Finding the distance will just be a number. So, if we are trying to find the midpoint that's in the middle of these 2 points, -5, -3, and 9, 3, we would use the midpoint formula, which says, take your x's, add them, and then divide by 2, which is basically just find the average of the two. Take your y's and add them, then divide by 2, which is just finding the average of the two. This is different than the distance formula. The distance formula is finding the difference, basically, of some of them and squaring them and then finding the full distance. This is just finding the middle of the 2 points. So it's like finding the average of each. So when I use the formula for this, if this is the first ordered pair, this is the first x and the first y, so this is x1, y1. This is the second ordered pair, so this is the second x and the second y. I'm going to take my x's and add them and then divide by 2. So this is going to be -5 plus 9 divided by 2 for my x coordinate. Then for my y coordinate, I take y1 and add y2 and divide this by 2. So here are my 2 coordinates that I'm just now going to simplify. -5 plus 9 is 4, and 4 divided by 2 is 2. -3 plus 3 is 0, and 0 divided by 2 is 0. So the middle point between -5, -3, and 9, 3 is 2, 0. That's the midpoint formula. So what we're going to do now is skip this practice example, because I want you guys to actually practice some of these formulas. And skip this and skip over to the next page that says here, find the distance between 2 points. It's really important that we understand how to use formulas. It's the only way you're going to be able to do well in this section is if you can get a formula. I give you a formula and I say find the answer. You put the numbers in, use your graphing calculator, or use your math skills to solve those using the order of operations, and then you'll be okay. As long as you have the formulas, you'll be okay. I'm pretty sure we'll probably be giving you the formulas and not making you memorize them because they're kind of long. But we'll see. Don't quote me on it. So I want you guys to take the next couple of minutes. Just try this first one. I'm going to check in with you in like 2 or 3 minutes, see how it's going, and then I'll explain the second problem. If you're ready to try the second one, go ahead. But if you're not ready for the challenge, just wait until we go over the first one.